Hi guys, good morning. Today we're going to review what we learned about factoring. Tomorrow we'll have a test on factoring. So I'm just going to go through the review, kind of explain my reasoning. But if you have further questions, please go ahead and let me know. Email me and work something out. Okay, so in this first section it says factor each expression. If there is not a GCF, rewrite the expression. What this section is actually asking us to do is just to factor out a greatest common factor, although the instructions are not very clear on that. So in this one, p to the fourth plus 3p to the third, the common factor is p to the third. This has 4p's multiplied together. This has 3. The ones they have in common are 3, so we take that one, bring it in front of the parentheses. That leaves p plus 3. Remember, you can always double check to make sure that it's accurate by multiplying back through quickly. So p to the third times p does give me p to the fourth, and p to the third times 3 does give me 3p to the third. So that's all it's asking me to do there. On number 2, there's actually no common factor, and so I would just rewrite it. You guys now know how to factor it using X factoring. You could factor it that way, but since this really was just asking us to factor out the greatest common factor, we're just going to rewrite it because there's no common factor here. If it asks you to factor completely, you're going to want to factor it all the way out. If there's any of this on the test, I'll put to factor out the greatest common factor instead of just factor the expression. It'll be a little more accurate. Okay. On number 3, we're supposed to find two numbers that multiply to m and add to s. So the easiest thing to do is just start making a list of factors. So, and I know it's negative, so I know one of my factors will be negative, but I'm just going to kind of ignore that for a second. I really am just looking to see if these two numbers will either add or subtract to -6. 1 times 40 will not. You would either get 41 or 39. 2 and 20 won't work because 2 plus 20 is 22 and 20 minus 2 is 18. We could do no, 3 won't go into 40. We can do 4 and 10, and there we go, because 10 minus 4 is equal to 6. We would want our 6 negative when we add these together, so we would make our 10 negative and our 4 positive, so that when we add them up, we do get that -6. On number 4, factors of -14 that add or subtract to 5. 1 times 14, 2 times 7, and there we go, because 7 minus 2 is equal to 5. So if I just make the 2 negative, those two work perfectly. Okay, now we want to factor completely. So this is where we want to first look for that common factor. We're going to factor out the greatest common factor, and then what's left in the parentheses, we're going to use our X factor technique. So let's first just look for our common factor. We have 10, 44, and 16. So it looks like the greatest common factor here is 2. I'm going to pull a 2, and that will leave me with 5n squared. Just divide that number by 2, right? 44 divided by 2 is 22, and 16 divided by 2 is 8. So now we're going to use our X factor technique. Up here we want A times C, and down here we want B. So A is 5. Remember, they're the numbers in front of the variables. B is -22, and C is equal to 8. So A is always the one with the squared term. In standard form, we always write that one first. B is always in front of just the x term, or in this case, the n term. And C is always the constant. So even if this were written in a different order, like 5n squared plus 8 minus 22n, A, B, and C would still be the same A, B, and C we've written down here. So this kind of depends upon this polynomial being written in standard form with highest exponent to lowest. Anyway, so A times C would be 8 times 5 is 40, and B is -22. So I'm looking for two numbers that multiply to 40 and add to -22. So I've got 1 times 40, which won't work. I've got 2 times 20, which will work. 2 plus 20 is 22. Again, we needed a negative 22, so we're going to make both of our numbers negative so that when I add them, I'll still get the negative 22, but when I multiply them, I'll still get positive 40. So negative 2 and 20 are our two factors, so we'll write those here in the parentheses. So we'll have n minus 2, n minus 20, and then don't forget we need to divide those by our a term. Now if they go in evenly or can reduce, do so. If they don't go in evenly and can't reduce, just take that number and move it in front of n. So this is going to give me 2 times 5n minus 2, and then 20 divided by 5 is 4. So there's our answer. Okay, on number 6, we have no common factor. Oh, yes, we do. We have an n. Every term has an n, so we're going to pull that n. So that will leave me with 5n squared plus 6n. And then if I have an n and I pull an n, sometimes students are tempted to put a 0 right here. But remember, if I multiply this n back through, I need to get the same thing that I got here. So I would need to put a 1 there, not a 0. All right, so then we're going to use our x factoring here. We have a is 5 and c is 1. So a times c would be 5. And then our b is 6. So for 5, I either have 1 times 5 or 2 times 3. And it looks like the one that adds to 6 is that one. So we'll come back over here. We have n plus 1 times n plus 5. And then we just need to divide each of these terms by a. So 5 will need to come in front of n. So we'll go in or reduce. And 5 divided by 5 is 1. Okay, so there's our result. That's the factored form. All right, let's move right along down here. 7 is a squared plus 3a minus 4. So again, check for a common factor first, but in this case there is no common factor. So instead we're going to start right away with our x here. Our a here is 1 because I don't see a number in front of a squared. So 1 times negative 4 is negative 4. Middle term is 3. So this would be positive 4 times negative 1 gives me negative 4, and 4 minus 1 equals 3. So this one would just be, oops, I'm tempted to put an x, but we need to put an a. So a minus 1 times a plus 4. I would divide each of my terms by a, but in this case a is 1. So if I divide them by 1, it's not going to change anything. All right, same thing here. We don't have a common factor. So we're just going to go right into x factor. 1 times 4 is 4. And then b is 4. So this time we'll want 2 times 2 is 4, and also 2 plus 2 is 4. So b plus 2. Oh, b plus 2, b plus 2. And again, we'll divide by a, but since a is 1, it's not going to change anything. So this one is b plus 2 times b plus 2, which I could also write as b plus 2 squared. And there we go, factor form. All right, looks like number 9 does have a common factor. 3, 18, and negative 81 do have a common factor of 3. So I'll pull a 3 out front first, which will leave r squared plus 6r minus, how many times does it go in? 3 goes in, 2, 8. 2 times with 21 left over, so that'd be 27. All right, we're going to do our x factoring over here. We got a is 1 and c is negative 27. Our b term is 6. So for 27, we have two choices, 1 times 27 or 3 times 9. Looks like 9 and 3 will work if one of them is negative. We'll want, since our result is a positive 6, we'll want the bigger number to be positive and the smaller one to be negative. So come over here and rewrite this. So 3 times r plus 9 times r minus 3. And so I'm just using those two numbers I just found, right? And then I need to divide each of them by a, but again, in this case, a is 1, so it won't change anything. All right, number 10, we have a missing term. The missing term is the middle term with x. So our b in this case would be equal to 0. So a is 5, b is 0, and c is negative 245. So you have to think about that standard form, ax squared plus bx plus c, in order to know which one should be 0 if there's only two terms. Again, I said a is always with x squared and b is always with x, and then c is always the constant term that doesn't have a variable with it. So because the missing term here is the one that would have an x with it, that's why our b is 0 instead of our c. All right, so we can still use our same x factor method here. I would need to go ahead and multiply 5. Ooh, before I do that, let's pull out a common factor. So let's actually, that is going to make things easier on us. So if I pull out of 5, I'll have x squared minus, and then 245 divided by 5 would be 40, let's see, 5 goes into, there'd be 4 with 45 left over, so that'd be 49. So we've got 5 times x squared minus 49. So we're looking, so now our a is actually equal to 1, and our b is still equal to 0, and our c is equal to negative 49. So a times c is negative 49, b is 0, so what multiplies to 49 and adds to 0? That would be negative 7 times 7. So 5 times x, no, yep, x minus 7 times x plus 7, with a equal to 1, when I divide these, nothing will change. So there we go. Okay, just a couple more here. Number 11, no common factor. So we'll just go ahead and we will multiply out a times c. So 5 times 12 is negative 60, I guess negative 12. And then our middle term being 28. So for 60, just start making a list. 1 and 60, that won't help us. 2 and 30. Oh, 30 minus 2 is 28, so those will work. I will want the 2 negatives, since our result is positive, we want the bigger number positive. And then just rewrite this as x minus 2 times x plus 30. Remember to divide each of these by our a, which in this case was 5. I can't reduce 2 over 5, and it won't go in evenly, so I'm going to move 5 in front of x. On this side, 30 divided by 5 is just 6. So there we have it. Okay, last one. There is a common factor of 3, so we will pull a 3 first. 30 divided by 3 is 10 n squared. 3 divided by 3 is 1, and negative 9 divided by 3 is negative 3. So there's our GCF pulled out front. So now we're just looking at what's in the parentheses. Remember, we're keeping our 3 there, but we're just kind of ignoring it. We want to come over here and make an x. So 10 times negative 3 is negative 30. And b is 1. So anytime b is 1, we want to look for two numbers that multiply to 30, but they're only 1 apart. So again, we can just start making our list. 1 and 30 won't work. That'll give me 29 or 31. 2 and 15 won't work. 3 times 10 won't work. 4 doesn't go in evenly. 5 and 6 will work. So our 1 is positive, so we'll want the bigger number positive, the smaller one negative. So negative 5 and 6 will be our two numbers, our two factors here, n minus 5 and n plus 6. And then we need to divide each term by a. So in this case, both of our fractions will reduce. 5 over 10 goes to 1/2. 6 over 10 goes to, whoops, I'm going to cross that out and I missed. 6 over 10 reduces to 3/5. Okay, and those won't reduce further, they won't go in evenly, so both of those will have a number in front. This will be 3 times 2n minus 1, and this one would be 5n plus 3. Alright guys, I hope this video was helpful for you. If you have any further questions, please let me know.